Okay, thank you. All right. Okay, yeah, welcome, doing Solar. Okay. All right. So today we'll be doing a live lab on Python, and what we'll be doing today is data wrangling. Okay, so what is data wrangling? Okay, so data wrangling divide, like I checked the definition because so okay, so data wrangling, sometimes referred to as data modeling, is the process of transforming and mapping data from one raw data form into another format with the intent of making it more appropriate and valuable for a variety of downstream purposes such as analytics. So data wrangling is just basically to, excuse me, to convert data into a more cleaner, just to clean our data. So most times the data we get as raw data, most times it's usually many a times there are many missing, there are some columns, many columns have missing values. There are values that are not wrong. So when we do data cleaning, something we try to do at times, we drop a column. At times we need to rename a column, and and at times we need to, for missing values, we need to change to drop our missing values, or we input some other values to replace our missing values. So, and one of our values we can replace to for the missing values is the mean. So mean is one measure of central tendency we can use to replace missing values. And another one we can also use is the median. Okay, so the IDE I'll be using for today is 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 Jupyter Notebook. And if we've been at the previous sessions, we would have observed that DG uses Google Colab. So Google Colab is one notebook that allows us to do our analysis. So we can even do an analysis and do our visualizations. But for today, I'll be using another one, which is Jupyter Notebook. And Jupyter Notebook comes with the Anaconda package, which can be downloaded. If you go to uh, Google, if you search out, if you search for Anaconda, you'll be able to download that. Okay, so now, so I'll be sharing all of my screen now. Okay, all right. So I believe we can all see my screen now. Can you see my screen? Okay, all right. So I'll be going ahead. Okay, thank you, Paul. Okay, so I already have Jupyter installed, so I'll type on Jupyter Notebook. Okay, and as you can see, it's coming up. So let's wait for some moments for it to come up. So, and apart from Jupyter Notebook and Google Colab, there are different ones. There are other ones we can use. There is Axiom. There is Spider also. Spider comes with the Google with the Anaconda package also, and there's also, okay. So we can see now that it's open. And we can also use Microsoft VS Code. So we can use any IDE to run it. Okay. All right. So what I'll be doing is I'll be creating a new notebook. Okay, it's coming up now. Okay. Okay, so we can see the notebook now and it's loaded. So, okay, so this is our code. This is our code cell, and we can see we can either make it a markdown or an edging. So the first thing we'll be doing is that we'll be importing our libraries. So for this one, I'll be creating a comment. So, and I will be putting in the comment import Python libraries. And the libraries will be importing to, sorry, and the libraries will be importing today is we'll be importing NumPy. So import NumPy as NP. We'll be importing pandas also. So these are libraries that allows us to do data analysis with Python. So import pandas as PD. And if we have any questions as I'm proceeding, we can always unmute our mics and ask the questions. Thank you. And import matplotlib as MPT. So we can, and even for pandas and all, we can choose to import it as anything. So once I click here, either I run from here or I click on Shift Enter. Okay, so we can see the code is running. So we can see that, okay. So once the libraries we are importing it's done, this number will come up and that's why it's showing here. Okay. All right. So the next thing we'll be doing now is we'll be importing our CSV file that I'll be using for the analysis. And just like I said, you'll be doing data wrangling today. And data wrangling is the process of converting data from initial format to a format that it's better for analysis. Okay, so I've imported my library. So, and the next thing I'll be doing now is to import the CSV I'll be using. Okay, and okay, so data. To, okay, and we are double quotes, so equals to double quotes, and this is the link. So this is the link of the data I'll be using, and there are different ways of importing data. So if our data set we have is not, so I'm pulling the data set from the object storage from here S3. So we can also import from our laptops, but this is the one I'll be using for today. So I will click on next. And the next thing I'll be doing after this, okay, okay, I see some chats. Okay, all right. So okay, so the next thing I'll be doing after this is for me to, so I can we'll be creating headers for our data. But first let's read the CSV and see how it is. So there's a question. Okay, I should share the link. Okay, so I'll be sharing the link now. Please give me a moment, please. I'm trying to share the link. Okay. Okay, so that's the link. So the next thing now is I'll be reading the file into, okay. So we imported pandas as PD. So we imported pandas as PD. So data.read underscore CSV. So that is how we read our data. Okay, and we put the quotes, data wrangling, and our file name, because this is what we call our file. So data wrangling CSV. Okay, then we enter. Okay, so we can see here. So this is the folder I already I read. So we can see that the folder is at the file data I read. It has no header and all. So okay, so something I can do for this is I can create headers. So I'll be using an headers that have already been created. So I'll be putting a headers equals, so these are headers that are already been created. So symboling, normalized losses, make, for type, aspiration, number of doors, body size, drive wheels, engine location, wheelbase. Okay, so I will click enter for here, and I will load my CSV again. So I'm loading my CSV again now. And after here, I'll put a comma. So it's the same file I put there, I'll put the comma. Then after that, we put names equals header. Then I'll load my CSV again. Okay, header, okay, yeah, sorry. And this is, so anytime we are doing our codes, most times we run into error. So when we run into errors, we see, once we see our error code, so we also see the reason why we are having errors. So this one is showing me that name error, header is not defined. So I will go back here and click on, so headers, and then I'll run my code. Okay, so we can see the difference here. The first time I imported it had no header, and a data that has no header, most times you don't know what you are working with. So if I show this data set to someone now, the person might not know what I'm actually doing. But once I show this to the person, then the person can know, okay, yes, so symboling, okay, this column is for normalized losses, this column is for the car make of the car, this one is for fall type, this one is for aspiration, this one is for number of points.
Modeling what are iconic symbol worship that represent worship.
Okay. All right. So and yes. So this one is for number of doors. Okay. So the next thing that we will now be doing now is, okay. So and mostly this is used for exploratory analysis. But yes, once we load our data, we can decide to see, okay, let's see what our data is. And another thing, we didn't name our data here. So let's go back here and call it car data set equals to, so it's the same code I put here that I'm putting in. So then I run it. Okay, then if it, so to view the first 5 rows of our data, what we use is we use a function that is called head. So what I'll be doing now is car data set dot head, and what that does for me, okay, all right, so this is another error that it's showing, and actually this is not what I want, so I'll have to go back. And something I said that most times when we are running our codes, most times we have errors. So it's because of the brackets I didn't put there, that's why I'm getting the error. And you see when I click here now, so it's showing me the first 5 rows, and that is what it does. So even if I want to go further and I want to view the first 20 rows of my data set, all I just need to put is I just put 20 inside here, and once I click here, you see it's showing me the 20 rows. And also, if I want to see the bottom rows of my data set, what I do also is to come here and write car data set dot tail. So by default, these functions, both tail and head, they show 5 rows. So once I click here, and you see that it's showing me the last 5 rows, and I can, okay, now decide that, okay, I want to visualize the last 10 rows of my data set. So what I just put here, I just put 10. And I click enter, and it shows me that. And another thing is I can decide that, okay, I want to I want to know the shape, the shape of my data. So what I do here is car data set dot shape, and it shows me that, okay, so I have 205 rows, then I have 25 columns. So this is what this does for me. Car data set dot shape. Okay, so I'll be moving on now. And another thing is okay, so I'll be moving on now. And the next thing I'll be moving on now is, as we can see, this data has a lot of commas. And what commas means is that they are missing variables. So there are missing values, and which may hinder our further analysis. Like we can't work with a comma in our analysis. So how do we identify all the missing values and deal with them? Excuse me. So steps for working with missing data: we identify the missing data, we deal with the missing data, and another one is to correct the data format. So in identifying the missing values, what we do is we will convert the question mark to NaN. And NaN is just, it's not a number, but it's Python's default missing value link. So that is what NaN is. It's Python's default missing link. And here we use the function dot replace a b in place true. Okay, so so what I'll be doing now is I'll be using the function. So just like we know, the data set, the data frame we are using is car data set. Yes, car data set. That is the okay, excuse me, I'm trying to, okay. All right, so can you still see my, okay. So car data set, that is the function we are using. So what I will do now is, okay, so and what I told you about markdown. So let's just create a markdown now. So and the markdown just means just string. So you put hash, and here I can say identifying missing values, and I put my sheet enter, and you can see now it's here. Okay, so what we want to do here is to replace. So we put here replace, we add a comment, and for starting a comment, you start with the hashtag replace question mark to NaN. And if you remember, I said NaN is the Python's default missing value marker. So for reasons for computational speed and convenience, so that's what we'll be using. And after that, we go forward to say car data set dot replace. So replace is the function we'll be using. That is a function we will be using for our missing link. Dot replace, we open a bracket, and we put in here a question mark, comma, NP. So we are using NumPy. If we remember, we imported NumPy at the start. So it's NumPy we are using here. Dot NP dot NaN. So NaN is the value we'll be using, comma, in place is true. So in place is just telling us that anywhere there is commas, it's going to look for them. As you can see here, there are commas here. That's just what in place is doing. Then once we are done with that, you can print out the car data set dot head to just show us how the data now looks now. So okay, so once you're done here, we run. And as you told you, we can either run from here, or we can use the shift enter. So most times I use the shift enter because it's convenient for me. Okay, so I'm going ahead now, shift enter. And yes, we can see now that, okay, so the first 5 rows the other time, yes, this were the first 5 rows the other time. And normalized losses, there was comma here, comma here, comma here. But yeah, let's look down. Let's look at it now. Now it's showing NaN, NaN, NaN. And we have identified the missing values, and we've replaced it. So that is the first thing we'll be doing. And now we've identified. identify the missing values. So the next thing we'll be doing now is evaluating for missing values. So the missing values are converted to Python's default. So we use Python's built-in functions to identify these missing values. So there are two ways to detect missing values. Either we use is null, or we use okay. So let me just make this a markdown. And another thing we'll be doing, I'll be sharing this later with us for anyone that wants it. So evaluating for missing data. Okay, then I come here. Okay, and I can also create a markdown. Okay, so there are two different there are methods to detect missing data. Okay, and the first one, okay, I can go back here and edit this. Data. So the first one is dot is null. So that is a function. Dot is null in brackets because it's a function. So all functions have brackets. And the next one is dot not null. So and what are the null and dot null? So it's null. It will make us look for data that is null in our data sets. So that is what null will help us do. And dot not null will help us look for data that is not null. Okay. So for this, I click on enter. Okay, I think it's because of this. It's recognizing it as a function. So I'll just go back here and click on. That's right. Okay. Once I'm done with it, and shift enter, and we can see it. Okay. Okay. So the next thing I will now be doing now is to also for the missing data, to check for my missing data. So missing data. So what data are actually missing in these values? And these are the data that have already been put in as NaN. So missing data equals to and what is my data set? My data set is car data set. So car data set dot is null. So I'm using the is null function. And just like I said, I'm closing with a bracket. And once I'm done with that, okay, so I will now print missing data underscore data dot ed. So most times when you finish doing a process, you click on dot ed to see how the process you've done, how it has influenced your data set. So and once I'm done with this, I click on this. So okay, so it has shown me now that okay, so false. So and what this just stands for. So now I create another markdown to explain. So true. Anytime we see true, true stands for missing values. So true stands for missing value. While false stands for not missing values. Okay, so it means that the values here are not missing. So that is why we see false. So another thing we will now do is now we can count the missing values in each row. So and okay, I see a chat message. How can we get a summary of the how can we get the summary of the missing values? Okay, okay. All right, so for that and dot, so let's use the function not null. Non missing equals car data set dot not null. Not underscore missing dot ed. Okay, so and this is another, so it's showing us true. So these are just this is just like a direct opposite of this. So so not missing, the values are not missing, it's not missing true, but this one is null, so it's null false. Okay, so Lucent, so we'll get to your question shortly. Okay, so to count missing values in each column, so and I think that's similar to what you asked, counting missing values in each column, and for this you talked about summary. So for this, we'll be using a for loop in Python, so we can quickly figure out the number of missing values for each column as mentioned. So okay, and for here, false means that true means represents a missing value. False means that the value is present in the data set. In the body of the for loop, the method dot value counts the number of true values. So okay, so now I will now be doing a for loop, and for this for column, so you can ask any questions as I'm going on. So for dot colon missing, so if you remember, missing data was what we used. Missing data dot colon. So now it's a lot of function, but just let me say this about just a best practices that professionals do, and this is also a question that comes up most times in interviews. So they ask you that what is the best for data wrangling, what are best practices? So best practices most people do is they already have these functions, they already have it in a notebook, in a Jupyter notebook, or in a Python notebook. So so for any data you are using, you're just substituting it. So it makes things easy for you. So when you get a new data set or you get a new project and want to work on the project, the values that you already have there, just go on with those values or with the functions that you're already putting in. So you just substitute. So it's just it's a faster process. Okay. So I'm doing a for loop now, dot column, and now I'm doing a value count, dot values dot to list. Okay, and now I'll be going on. Now print column. So all our column, print. The next thing to do is print our missing data and column dot. So now we are using value count. So value count counts the value. So dot value counts. Okay, and because value counts is a function, that's why I'm putting this. Then lastly, print. Okay, all right, so once I'm done with it, I'll click on enter. As no, okay, data set has no data frame object has no attribute that is called column. Okay, all right. Okay, I'm trying to. Sorry, moment, please. Okay, so I think this is where the problem is from. Okay, yes, good. Okay, so so we can see our function now, and it's showing our different columns. So it's showing, and as you already know, first means that there's no null data. There's no null data in the data set. And okay, so you can see here, symboling is symboling. There are 205. there are 205 columns that are not empty. Then for normalized losses, there are 164 columns that are not empty. So, and there are 41 columns that are empty. So I think, Lucent, this is like, this also shows a summary of what you were talking about. Then here, this also shows us the column type. So D type is showing us this is an integer column. And this is showing us that false. So 205 columns are not empty. So, and 205 columns are not empty for aspiration. For number of doors, the number of empty columns are 203. The number of non-empty columns are 203. Empty columns are 2. Okay, so the summary just keeps going on for each column. So we can see here, and this is how it goes on for each column. So it summarizes all columns. Okay, so based on the summary above, we can see that each column has 205 rows of data, and that is something we did at the start. And we can also do that. Car data set dot shape. That is a quick way. Okay. Car data set dot. Okay, so we can see the shape, and the shape is showing that okay, there are 205 rows. So okay, so each summary is here. Okay. So now we'll now be going to how to deal with missing data. So if there are any questions at this moment, you can unmute your mics and you can ask. If you have any questions, you can unmute your mics. Okay, I see a question from. Okay, I see a question from Ifeoluwa. What does the last line of the code print do? Okay, it's a for loop. So we use this to end it. So let's try our codes without it. So it still prints the same code, but what this just does, okay, you can still see it, but when we add this unexpected index, okay, you can see it separates it. So before they were together, so I'm going back now and I'm clicking it. Everything was together, but the line of code, it separates them. Okay, so I'm pasting back now. Paste, and not to get the index error as I got the other time. And you can see now that it's separating it, not to model it up. So that is what the line of code does. Okay, so the next thing we'll now be doing now is dealing with missing data. Okay, and just like before, so I'll create here. I'll go to a markdown, and for my markdown,
yeah, not even with the news because we cannot use it. Tell I know I things are okay. Tell I know I things are problems.
Data. And I go on. Okay, so these are just headers and the markdowns. So how to deal with missing. So how do I deal with missing data? So how to do with missing data for a comma and shift enter. So this is just what this does. Okay. So to deal with missing data, so these are the different process, various things we can do. So the first thing we can do is we can drop the data. So that is the first thing you can do. And in dropping the data, you can decide. So you can drop the whole row. You can decide to drop the whole row. So maybe we see that a row has when we are doing our data wrangling or our exploratory data analysis, we see that okay, a row is repetitive, and we don't want it to have an impact on our analysis. So we can drop the whole row. Another thing we can do, we can drop the whole column. And another thing we can do is to replace it. So maybe you still need the data and you can't drop it. You can't afford to drop it. So something you can do is to replace it. And what you can do to replace it is that you can replace, we can decide to replace, replace it by mean. You can decide to be, we can replace it by frequency. And also we can replace it based on other functions. And I'll just add a third one, a fourth one. You can also replace it by median. Okay, and okay, so I've been doing all the talking. So okay, so I'll be asking a question now, and I want us to we can either omit ourselves or we can type in the comment box. So why do we replace missing data by mean? So I'm expecting responses. So why do we replace missing data by mean? Okay, all right, so I'll go on. Most times, the reason why we replace missing data by mean, just like we know that mean is a measure of central tendency. So what measure of central tendency means is that what the data tends to be at the center. Excuse me. What?
Hello.
Okay, all right. Please go on.
So I would like to answer that question.
Okay.
So I think we basically replace our missing values with mean when we have a normal distribution.
Okay.
Yeah.
All right. Okay. Okay, so why do we replace it? You said we replace it when we have a normal distribution, but why do we replace with mean? Okay, I think it's unmuted. Okay, so one reason we replace with mean most times, okay, and one reason we replace with mean most times is that most times mean is what the is a measure of central tendency. So maybe we have different data that, okay, I'll just give an example. There are 10 values in a column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Once you look at the mean for that data, you can see that the mean most times it might tend to be maybe around 6 point something or maybe 7 point something. I'm just giving an example. So the reason we use mean is because that is what the data tends to be at the center. So that is the center of the data, and that's like, well, so when we are replacing our data, it's just like the best value that we can think of it. So that is what we replace by mean. But most times when we use mean for small data sets. But when we have big data sets, most times what we do is to replace with median. So we will use median, and we can also use frequency and based on other function. So I'll going on with this. Okay. So and whole columns should be dropped only if most entry of the columns are empty. So the only time we should drop the whole columns is only if the most entries of the columns are empty. And maybe we don't also need the column for analysis, so we can decide to drop that. And okay, so for normalized losses, for normalized losses that add 41 missing values, so we replace them with mean. For stroke that add 4 missing values, okay, for borders 4 missing values, so we replace with mean. Stroke 4 missing values, we replace with mean. Horsepower 2 missing values, we replace with mean. And peak RPM 2 missing values, we replace with mean. And number of doors 2 missing values. So where's number of doors? Okay, so number of doors is somewhere. Okay, so number of doors, we replace with frequency. And price. So price, and we will be dropping the whole columns for price. Okay, so because of time, let me just copy and paste this here for us. Okay, so I'll be going back here and I'll be creating it to be a markdown. Okay, so okay, all right, and what I do, okay, so row column should be dropped, so we can read through this. Okay, Okay, so the next thing I'll now be doing now is I'll be calculating the average of each column. And the first, okay, so how to calculate the average? The average, so okay, so average of, so the first thing we'll be doing is we'll be calculating the average of norm loss. So average of normalized losses, norm loss underscore loss equals to data frame, and our data frame is car data set. This normalized, okay, I think it's normalized losses. It's normalized. Yeah, normalized losses. Normalized losses. And that is our column type. And what is the type? The type of normalized losses is here is the type here is integer, is int64, and int64 are just numbers, but we won't be using integers, so we'll be changing it. And what we do is we're using the AS type function, and we'll be changing it to float. So our float is just decimals. Float, and once we are done with that, dot mean, we'll be looking for the mean, and axis equals 0. So, and okay, under which, okay, someone is asking, under which instance do we replace values with median or frequency? Well, most times when the value is small, and it depends on the column also. Okay, can I explain again when to choose mean, median, or frequency in replacing? Okay, so most times when you replace with frequency, you replace with frequency for a normal distribution, and most times with a small data set. So that is most times when you choose the mean. But for larger data sets, the best you will get a better you'll be getting a more cleaner data by using the median. So that is when you use the median. So for smaller ones, you use frequency. For normal distributions, you use mean. But for larger data sets, you use median. So if there are, I don't know if you're clear. And even for now, for now, data sets that are larger than that. For data sets that are larger than that, there are other functions we can use. So and that is where this function comes in, k-nearest imputation. So we can use k-nearest imputation for that. So k-nearest imputation just means that, okay, that is more of machine learning. So k-nearest imputation just k-nearest imputation there's k-nearest means. So k-nearest imputation, there's also k-nearest neighbors. So k-nearest imputation just helps you find a better data. So so that is a step ahead of it. But for here, I will just be using mean. So we set axis as 0, and we already know that axis, just like axis, zeros and 1. Axis most times are zeros and 1. Okay. So the next thing we now be doing now is to print it. So okay, I'm not done with this, so I just go back. Okay, so now I'll be printing it. Print creating. Anytime you see this, just know if it's used for a column name or it's used for letters. So print average of normalized losses, and that is just our mean. Average of normalized losses. Okay, and yeah, average of normalized losses. Okay, and there are two. Let me start again. Okay, so print. Okay, average of norm losses. So I'm just shortening that. Average of norm losses and comma. Okay, so and the average that we put here, average underscore norm underscore loss. So once we're done here, I will click here. And okay, so we can see that the mean for the average of normalized losses is 122.0. So let's see another thing we can do quickly, instead of going up, you can just quickly visualize it by dot end. Okay, so norm losses, okay, 164. Okay, so it's showing us that the mean is 122. Okay, so and another thing we'll be doing is, so okay, so let's calculate the mean value for ball column, and for this also, average underscore ball equals to car data set. Okay, and the column is ball dot as type. We are converting it to floats, and we are looking for the mean. Dot mean. Okay, axis, where the axis is 0, axis equals 0, and okay, and when we are done here, print average of ball, just like for the first function we did, comma, then have avj underscore ball. Okay, and we can see that the average of ball is 3.32. So the next thing that we now be doing here is to be replacing it, because that is actually the main idea of our data wrangling. We want to replace. So replace NaN by mean value. Okay, so for this, all we now do is our car data set. That's our data set. Open the brackets, ball. So ball is our column. So yes, is ball. Dot replace. If you remember, we use this replace when we replaced our commas by NaN. Dot replace. Then this is a function. So this opens NP numpy dot NaN comma avg underscore ball. That is our mean, comma in place true. So where all the missing values are now, to replace that. In place true. Enter. And this shows that it has been replaced. And let me see here, ball. Here's ball. Okay, ball is not here, but normalized losses is here. So just the same way we can do here, I'll just copy this for it to be faster. Car data set to be replacing norm losses also. So what is the name of the normalized losses? So I'll just be moving in here. Norm losses dot replace, and what is the name of our for our mean? I mean here is avj underscore norm underscore loss, avj underscore norm underscore loss. Okay, place true, yes. Yes. So okay, so let's visualize. Last time this was how our data set looks. Now let's visualize our data set. Car data set dot head. Voila, yes. And we can now see now that all the NaN, the missing values we had, they have now been replaced with the mean. So that is a way for us to replace our mean. And just like the same way we did with mean, that's the same way we do with median. We calculate our median and we replace it. Okay. I will calculate our median and we replace it. So and that is just the same way. Okay. All right. So our time is almost ended. So I'll just show us now how to check data type using pandas. So in pandas, this is just how to check data type for all data type using pandas. And this was what we used here. Yeah, so that's the type. Okay, yeah, we can only check for columns. So what do we do here? Just like we did here, car data sets. Yes, just like we did here. So create a column because we are checking for each one. Okay, so let's check ball. Let's check ball now. That's the type. And we can now see here the type is O. Or change it to integer, change it to float. Okay. So okay. So for pandas, dot the type allows us to check it. So this should data sets dot the types. I think that was a mistake I made. Okay, yeah. So we change our normal, so we can see a normalized losses is object, symbol is int64, float. Then okay, so we can see here. And if we want to change it, what we just do is for us to if you want to change it, what we just do is to AS type just like we did here, and we change the format for each one. Okay, so the next thing now we now be doing now is to convert data set to proper format, and that's the last one we'll be doing for today. Then if you have any questions. So car data set. Okay, so let's look at this data set very well. So there are some data that are not the type that you want it to be, and that is normalized losses. So normalized losses here is object, but we want it to be integer. Price here, we want it to be float. Price here is object. And pick prime, we want it to be float. So what we do here, car data set, bracket, put in here, or that is our first column, comma. And we can decide to use single quotes or double quotes, anyone that works for us. Stroke, and equals to car data sets, open the bracket. Just it's the same thing here that's here, because we are replacing it. We are just like we are, this is just like we are saving on top. So I can as well copy this and post this here. It's the same thing. But at the end, we now add .as type. And what AS type we want to change it to? We want to change it to float. So float. Okay, so now I'm moving to the next one now. And the next one now, car data set. So which data do I want to change again? I told us that we are changing normalized losses also. So normalized losses. Did I get it right? Yes. Okay. And what are we changing normalized losses to? We are changing normalized losses to equals to .as type. We are changing it to integer. Okay, and next one, enter. The next one I'll now be doing now. Okay, is the price. I want to change the price also. So car data set, the same bracket, price. Now what do I want to change my price to? So my price is in objects now, but I don't want it as objects. So I change the type to float.as type float. Float. Okay. And the next thing, so the final one, car data set. I want to change peak. So peak RPM, you are correct, equals, so let's do this. Dot AS type floats. So anyone, this is a double one. Okay, and once you are done with this, what do we do is enter. Normalize losses. What's showing this? Okay, but let me just do this because of our time. This is showing an invalid syntax in line 4. After floats. Okay, I don't know why this is coming up, but let's just try one. Let's try for this role. I think it has something to do with the commas and all. Wow. So I'm running into error, so I'll just try another method. So just like the method, just like the method we use it. So I don't know why it's giving error. Actually, it shouldn't give errors. Okay, so just like we change here. So let's convert our AVG back into int. Sorry, I'm running into a lot of errors. That's just how analysis is. You run into different errors, you come back, you check it, mention, okay. Now this is not the one. So it's now, what's the normalized losses is now object. Normalized losses is now object. It's now object. And this converts it to int. So once we go back here and click on our D types, It's only converting this. Car data sets. Let's run our data type again. Okay, so we can now see that normalized losses is now float 64. Here it was object. So the code we tried out that time should run. I don't know the exact reason it wasn't running. So okay, so we've already exhausted our time. So I don't know if there are any other options. So that is all on. That is all. So we've now cleaned this data with no missing values and all data in its proper format. So okay, at this point, I will ask us. So are there any questions? If you have any questions at this point. We can unmute our mics. We can unmute our mics. So for all we'll be doing since morning, if you have any questions, so you can ask. Okay, the data set used for the session. Okay, so I'll be sharing you the. Okay, so this is a link of the data set that was used. So I'm sending it in the chat now. In a moment, please. And I don't know if anyone here is on. We have a Telegram group where we discuss. So maybe you are working on something and you are having errors. So you can. So via our Telegram group, we discuss, and it's also a community of awesome data scientists. So, and if you're having any issues with your analysis, you can always post your questions on the group and your questions will be answered. So I'll be sharing the link to the group also now. Okay, so that is the link to the Telegram group. All right, so Oluwa Tony Adebi. So thank you everyone for joining. So please, if you have questions, please you can unmute and ask your questions. Or you can type them in. Okay. All right. So this is the link to the data sets that was used, and I'll also be sharing this. Okay. So something Deji always asks us to do, I didn't do. So always name your notebook. So data wrangling. And okay. All right. So this is a data wrangling notebook, and we are done now, so we can see. Okay. And for this, I will also be sharing the link to this. I'll be uploading it on GitHub. So hopefully we get to that in other sessions also. So GitHub is where we can put in our portfolios. So I upload this on GitHub. I will share the notebook on GitHub, and from GitHub we can download it. And then I also share the link to the CSV that was used also on the Telegram group. So so thank you everyone for joining another episode of Dear Analyst. So please do enjoy the rest of your evening. Thank you all.
Thank you, Tony, and have a nice night.
All right, thank you very much. And you too.